Okay, right, so now the next question is asking you to use the patterns in table in question 3, but this time notice that they're asking you for a situation where the number of integers is even. They're all got an even situation. So actually notice that we want an expression for addition triples when the list has n integers and n is even. So actually, if we do that first, that will help us to do A and B next one. Lord knows why I didn't ask you to do that first, because then A and B become very, very easy. But finding the nth term here is not so easy. Let's look at the table. These are your even situations. Okay? So we need a formula to connect them up. So we've got n is 4, 6, 8, 10, 12, 14, and we've got y, we're told, is, what was it, 2, 6, 12, 20, 30, 42. Okay, now if we use the same kind of logic as we did before, I think what we're going to do is we're going to try and get the numbers 1, 2, 3, 4, 5, 6. And that's easy to do if we divide by, subtract 2. So subtract 2 to each one. 2, 4, 6, 8, 10, 12. And then divide by 2, we end up with 1, 2, 3, 4, 5, 6. So we're going to take n, we're going to subtract it by 2, and we're going to then divide by 2. Now we've got to connect that up to these numbers here. Now notice that you could actually use the algorithmic way of doing this, of doing a quadratic sequence that Mr. Angus would have taught you, or you can spot something here. Look at each of these numbers. 2 is 1 times 2. 6 is 2 times 3. 12 is 3 times 4. 20 is 4 times 5. Hopefully you get the pattern. 5 times 6. 6 times 7. And this piece here, okay, well that is the same, as the number you're getting here. Okay, which is n minus 2 over 2. Okay, the next one is going to be, this is the same number as this. You see how it's just sort of shifting on 1. Okay, shift on 1, shift on 1. Okay, so actually the next one is going to be n plus 2, because we're always adding 2 each time. Adding 2 each time. Okay, take away 2 and then divide by 2, which is the same as n minus 2 over 2 times n over 2, which is the same as n times n minus 2 over 4. And there is my formula that connects y and n. Very, very tricky stuff. But if you manage to achieve that, part A and part B are very, very easy. Okay? Let's have a look at what it would be. We're just simply going to substitute in. So y is going to be equal to 100 times 98 over 4. And we'll use a calculator. 100 times 98 divided by 4. There must be 2,450 addition triples. Okay, if there are 1,332 addition triples, how many integers? Okay, times both sides by 4. So 1332 times 4 equals 5328 equals n squared minus 2n. And so that's a quadratic equation. N squared minus 2n minus 5328 equals 0. You have got a calculator, so you can use the solver in your calculator for this. I'm just going to put it in now. So I want f2 for polynomial. should remember how to do this. Degree 2 because it's quadratic. A is equal to 1. B is equal to negative 2. C is equal to minus 5, 3, 2, 8. And I get answers of n can be equal to 74 or n can be equal to minus 72. Well, n is not going to be minus 72. We can't have negative integers for this particular question. So there can't be minus 72 numbers of integers. It doesn't exist. So the answer is 74. Okay, job done. I do find this question a little bit ridiculous because they asked you to do this last, when actually in doing this, it helped you to do these. So you do not have to do the questions in order. Read everything and decide for yourself what is the most logical and easiest approach to take. Okay, so that concludes